Okay, so before we get going here, kind of doing review, a couple of things I want to mention before we get started. So on Canvas, if we're thinking about what is going to happen before tomorrow's midterm, you've got that uh, June 29th daily quiz that's due, was due before we started class today, so that kind of deadline is passed. The daily quiz that we had from yesterday that we went through, that one will be due before we'd usually start class tomorrow. Now, obviously, we have the exam tomorrow. I would suggest getting that done by the end of the day today. We also have that first Canvas discussion, which doesn't show the due date here, but we kind of had that due date set to be by the end of the day as well. So you can kind of see a lot of people have already kind of completed that. So the other thing that we had was quiz number two. So if you completed this, you should be able to see which problems you got right, which ones you got wrong. I can't display the correct answers because it's not due until the end of the day today. At the end of the day today, I'll kind of have all those answers released so you can see what the correct answers would have been. If you got one wrong, right, even though you can't see the correct answer, I would try to rework through those, right? And if you have any questions on those, you can send me an email. Once again, I'll try to respond as quick as possible after 4. I'll be in the office today and have one more section to teach, so I'll keep an eye on my email today before I head out at 4 p.m. Other than that, that should cover everything. So after the first midterm, which is tomorrow, and I said it's going to be open, I've have the time set to be 9:30 to 3:30 p.m. So once you start, you'll kind of have 75 minutes to complete it. You can't pause the clock. It requires the lockdown browser. Um, so if you want to turn it in by 3:30, you must start it, what, by 2:15. So I'll post an announcement that has the exact instructions that are given at the very beginning of the exam before you start it. So you can kind of read through those before you start the exam so you don't have to waste any time with that. After class today, I'll post up some of that next module reading. So that's due before we start class on Monday. So you kind of have the weekend. Friday, I know it's the 4th, so hopefully you find some time in there. Maybe even do it tomorrow after you take the exam. Other than that, we'll just kind of jump into review. I've got a question here. I'll make sure. So do students often run out of time? So to be honest, this is the first time I've taught this class in the summer. So primarily, I've always used in-person exams. I think time is an issue, so that's one of the things I can play around with to make an exam more or less difficult. So if you're kind of getting stuck on a problem, this applies to any class, but I would try to, move on. Like if you can immediately, like I'm not really sure, move on to ones that you feel more comfortable with, kind of work through those, and then hopefully you still have plenty of time to kind of go through every single question. But just in terms of, test taking recommendations, that's kind of how I would approach that. Okay. I think time will be an issue. There's 25 questions. On the quizzes themselves, there's 20 questions and you've got 60 minutes to complete them. So time per question really is about the same. So kind of your comfort, how comfortable you are with those quizzes should be about how comfortable you are with the exam. Now, I would say the difficulty level of the questions is a little bit higher. You'll kind of see when we work through some stuff today. I'll combine some multiple concepts, so time might be a little bit more of an issue than those two quizzes up to this point. Any other questions before we kind of jump into some review here? So if there's any specific questions, I can start with those. I've got a set of questions after looking at the exam that I think might be good to work through. But it's kind of up to you, those of you who are here, kind of what we'll go through. Okay, so I'm not seeing anything in the chat. So let's kind of think. I've got some ones that maybe don't show up on the quizzes or the practice problems. So let's say I've got an example and I'm given consumption, investment, government spending, exports, and imports. Okay. So maybe this is something like keep the numbers kind of nice and easy here. So 2000, 1000. We'll do 1,000 here. Exports are 500. Imports are 250. So if I wanted to use the expenditure approach, right? These were all of my expenditures. We said we take C plus I plus G plus exports minus imports. Okay. So how would I calculate GDP here? I add these values up, subtract my imports. I have what? 3, 4,000, 4,500. So 4,250. Okay. All right. Now, if I asked you, assume that we've got kind of wages. Oh, here, what do I want? So I want to make sure these values are going to work for us here. So I've got wages, I've got rent, interest paid on capital, profits, depreciation, and then we said kind of indirect business taxes. All of these were income. So if we use the income approach, we add up all of these values. Okay. So let's say I tell you rent is 500, interest is 1,000, profits are 500, depreciation is 300, taxes are 200. So if we're using the income approach, we would add up all of these values. So what I've got, what, 2,000, 2,500 if I add all of these up. If I ask you what wages are, right, and I could leave out any one of these components, right? I could leave out exports, I could leave out depreciation, but if I give you information on everything else, what should be true, right, because we have this circular flow to the economy, is that when I calculate GDP using the income approach, it should be the same as my GDP using that expenditure approach. So we've done both of them. So my expenditure approach, I had 4,250. My income approach, I've got wages plus 2,500. Okay. So when you're taking the exam, I would have a calculator in front of you to kind of do these calculations. Um, so in this case, I've got one equation, one unknown. What must wages be? 4,250 minus that 2,500, right? If I'm trying to solve for wages. So I have what? 1,750. Okay. So if I give you everything, but I leave out one of these components, you can solve for that because you know that the expenditure approach should give you that exact same GDP as that income approach. Okay. Any questions on that? Sorry, so I got the chat here. So your score will be, sorry, I didn't see that until we start working through this example. Your score will be hidden until after that time passes. Okay. One thing I want to point out in this type of a question that might be helpful is if I don't know imports, don't forget that we're subtracting them, right? So there's always going to be a negative sign out front. Okay. So I asked you for the value of imports and I give you information on everything else. Remember that it shouldn't be a negative value. We're looking for what that import value is. We're just subtracting it out in our equation. Okay. Any questions on this one before we keep moving? Okay. Um, Another one I said I'll kind of try to focus a little bit more on module 3 here. So I'm going to use Excel here kind of just to do our calculations. Um, I'll kind of write some stuff out on the dot cam here in a second. But let's say that I've got four different time periods, right? And I'm going to do quantity of good X, price of good X, quantity of good Y, and the price of good Y. So I've just got two goods here in my economy. If I wanted to calculate my nominal GDP, right? So let's say in this example, I've got my base year is 2022. I could technically choose any one of these years to be my base year. We won't go through every single one. I'm just going to go through the years that we're going to use in this example. So let's say in that base year, my quantities are 300, prices are 25. We'll do 200 over here, and we'll do prices of 50. Okay. If I ask you what would be my um, real GDP, I could ask you for the nominal GDP. I could also ask you for my CPI. Okay. And I'm going to do this instead for the year of 2020. Okay. But when I'm calculating nominal GDP, that's probably the easiest one. Okay. My nominal GDP, right? So I'm going to have to look at 2020. So I need those quantities and prices. So let's say I've got 250 and 20. And let's say here I've got 300 and here 35. Okay. To calculate my nominal GDP in 2020, it's simply the quantity in that year times the price of that good plus the other good's quantity times the price of that good. So we can kind of write this out, right? By hand. I'm just doing it in Excel here, but as we go, I'll write this on the dot cam and I'll kind of switch at the end so that we can see this. So nominal GDP was equal to what? 250 times 20 plus 300 times 35. So my nominal GDP is what? 15,500. Okay. Now, if I'm calculating then what I'm going to do is use my current year's quantities, but I'm going to look at the base year's prices. Okay. So I would take my quantity of the year I'm looking at, multiply it now by the base year prices. I would do that for each one of these goods. Right. So if I'm writing this out, calculating kind of that, excuse me, real GDP, whoops, which should be equal to what? 250 times 25 plus 300 times 50. So if we hit enter here or enter this into our calculator, we get 2,150. Okay. So what should the CPI always be of my base year? Okay. Well, if I'm looking at my base year, the prices I use for both real and nominal GDP would be 100. Or sorry, would be the same, which would always give me kind of the same real GDP, the same nominal GDP. And so there, I'd always have a CPI of 100. Okay. Any questions on that before we keep moving? Okay. So if I instead want to find my kind of CPI, right, that's the kind of final part that I'm looking for, then what I want to do, right, to calculate my price index. So my price index, I'm going to write this down so we can see it here in a second, will always be the cost of today's market basket over the cost of that same basket in my base year, right? Or I can think about this kind of like nominal over my real GDP. So in this case, right, what is my real nominal GDP? Another way of defining this, just to kind of make this clear. So here we're using the year that we're looking at, we're using those prices. So that's cost of today, right? Oops, I didn't want to do that. Cost of today. And then if I'm looking at real GDP, I'm looking at kind of the base year prices, right? So this is the cost in my base year. Right? So my CPI value will be the cost of those goods today divided by the base year. Right? Now, here I can kind of look at this right away and I see this is going to be less than one. And the reason why is like, even though quantities kind of went down here, notice the prices went up by quite a bit. Right? So when I'm looking at that base year of 2020, when I'm calculating the CPI sorry, base year of 2022, when I'm calculating the CPI of 2020, if prices go down, that CPI should be less than 100, right? We know that in the base year, the CPI would be 100. So here I get 0.72. I made a mistake, right? So I'm close here, but what did I forget to do? If I'm calculating the price index, remember, the price index in my base year will always be 100. So we're looking at price indexes of different years. Yes, they can be greater or less than 100, but they're not going to be like 0.7. So what did I forget to do here? When we're calculating the CPI, we always multiply by 100. Okay. So I get here my CPI in 2020, if the base year was 2022, is approximately 73. And I could go forward in time as well. I could set the base year to 2020, then calculate the CPI in 2022. In which case I kind of see inflation here, which actually increases the average prices or my CPI. So if I had the 2020 as my base year, I'm going to find that the CPI of 2022 would actually be greater than 100. I can kind of go in either direction there. So let me stop my share here. So we kind of had all of that written down. We calculated kind of nominal and real values, or we said the cost of today divided by the cost of the base year. So here we had what? 15,500 over, oh, I missed something, right? This was 21,250. So over 21,250. We said, what did we forget? We need to still multiply by 100. And that gave us that value of approximately 72.94. Okay. Any questions on that one? Okay. Um, That's another good one that we can go through here that I know is going to be important. So let's think about one where I'm looking at growth and I'm comparing kind of nominal to real values. Okay. So let's do an example where I'm thinking about what's going to be true, okay, if I have inflation. Okay. Then I ask you about what's true about the real and nominal growth rates. Okay. So if I have inflation, right, and we think about how do I calculate my real GDP, it's always going to be my nominal GDP or nominal value from that year. And then we said it's going to be divided by this GDP deflator, right? Real GDP is trying to control for prices. Well, if we remember, what is my GDP deflator? It's very similar to the example that we just worked through. It's just that instead of defining this as today, kind of my, or today over the base year, this is going to be my nominal kind of value over my real value, right? Or I can think about this as we said, if I have the same quantities, this is really like my CPI in the old time period, maybe over the CPI of my new time period. Okay. So here, if I've got inflation, right, I know that, oh, sorry, I'm looking at the same time period here. I don't want to confuse you here. So let's just think about nominal real. I think I can can make the point easier with this. So if I have inflation, what's going to happen, right? So let's assume we start out, we don't know the GDP deflator, but I've got real GDP of, let's see, so let's do my nominal GDP of 800 and my real GDP is 500. Okay. If I'm then thinking about if I have inflation, what's going to happen? Well, if I have inflation, nominal GDP doesn't account for that. So if I account for the fact that prices are higher, my real GDP is going to be lower than my nominal GDP. Right? So if my real GDP is lower, right, than my nominal GDP, this fraction is going to be greater than 1, or, right, I forgot I'm multiplying by 100, so it's going to be, sorry, greater than 100. Okay. So if I have kind of inflation, as that inflation increases, that's going to push this GDP deflator to get higher and higher. Okay. So if that's the case, right, if that GDP deflator is going up, I have higher levels of inflation. If I'm dividing by a larger value, maybe now my nominal GDP of 800 is going to become even smaller than before. Okay. So let's say this is kind of our base example, right? We can see that when I'm looking at nominal GDP, it's always going to be greater, right, than my um, real GDP. Now, if I had an example where, let's say, um, I could even complicate this further. So let's say that in 2024, my real GDP was 500. My nominal GDP was 800. Okay. And then in 2025, it looks like my nominal GDP goes up to 1,000, right? But once I adjust for prices, right, I know that that real GDP is going to be lower. Let's say that the GDP is only 600. Okay. Well, if I'm calculating my nominal growth rates, right, because this GDP deflator is going up, I've got inflation, then that's going to cause me to have lower real GDPs. So if I'm looking at that nominal growth rate, right, then that growth rate is always going to be larger than my real growth rate. And I could even think about it, maybe another example. Let's say my nominal value goes up and this real growth rate goes down to 500. This maybe kind of really emphasizes the point. I would still have growth, calculating my growth rate using nominal GDP. So if I'm thinking about this growth rate using nominal values, well, if inflation is high enough, right, I could end up with the same real value year to year. If I keep producing the same amount, but the prices have just went up, it must be that I have less real value, right, to my income, or in this case, less real value to my GDP. So even if nominal GDP changes, if my real, it could cause my real GDP not to change at all. So my growth rate here, right, is actually going to be equal to 0. So this is an extreme example to go to kind of point out the growth rate, if I'm calculating it using nominal GDP, will always be greater than my growth rate of real GDP. Okay. And that's because nominal GDP captures growths in both output and prices. Real GDP captures those same increases in output, but not the increases in prices from inflation. Now, if I worked through an exact same example, but I told you that there was deflation, everything gets reversed, right? This now potentially is less than 100. That decreases this price deflator, which would actually increase my real GDP, in which case now I know that that growth rate of my nominal GDP must be less than the growth rate of my real GDP. So I could give you an example where we start out with either inflation or deflation. We would have the exact opposite kind of outcome. Okay. Any questions on that idea? Going to show you one more way to think about this. Um, so let's say I have my base year, and then I'm going to kind of the following time period, and we'll go back to the example where I have inflation. Okay. Well, in my base year, what must be true? So maybe if I have a question, I give you information about 2024 and 2025. I don't want to say I'm trying to give you any tricky questions, but this one would maybe be a little bit, it might be easy to make a mistake. What will the real and nominal GDP always be in my base year? Well, in my base year, right, I'm using the same prices, right? We kind of have the other example, my market basket today and tomorrow. Well, in the base year, those prices are exactly the same. So I would have real GDP that's exactly the same as my nominal GDP. Okay. If I have inflation, I know that the following year, even if my nominal, even if my nominal GDP goes up, yes, my real GDP could go up, but once I adjust for price increases, we kind of go back to that fact that the GDP deflator would be higher, in which case my real GDP increase isn't going to be as large. So I could actually go through and calculate my growth rates here. So if I had 600 minus 500, that's the change in my real GDP, dividing it by where did GDP start out, 500. Well, if I have my growth rate for nominal GDP, that's 800 minus 500, but I still have kind of that same kind of starting point. So if the denominators are the same, the numerator here is always going to be smaller. That's the situation where we said nominal GDP is always going to be greater than my real GDP. So just to kind of, this is real, this is nominal. Okay, so just another way of thinking about that one. If it helps to think about that older time period before inflation occurred, if you think about it as your base year, I think it makes it a little bit more easy to think about why that growth rate is always higher for nominal GDP. So with inflation, could real GDP go down, or is it always still an increase? Technically, it could go down. What would have to be true if I had inflation, right? But I still see that my real GDP was like higher than before. So like in this situation, I've adjusted for inflation, but my real GDP is still higher. How did that happen? It must have been that the increase in output was larger than that change or increase in prices. Okay. Um, but this is maybe why it's a good way to think about it this way, because that increase in output is still captured by my nominal GDP. It's just that it also captures my prices. Once I adjust for those prices, I could think about real GDP is really only capturing the increase in output. Any questions on that before we keep moving? Okay. Um, let's think about another one we could work through here. So I'm just making sure I keep an eye on time. We'll go back. I've got another growth rate example we'll work through here later. Um, and just to make, I also want to make a point before I move on. So on the exam, I try to indicate this. I add this, I shouldn't say try. I do indicate this and add it to the problems. If I'm ever asking you about growth rates or inflation rates, I will always tell you to enter them as a percentage, right? So there is no question where I have you enter the decimal form. Now, in our calculations, we might need to use the decimal form, and we'll see that in the growth rate example I'm going to do um, later on, right? But if I ask you for the growth rate and either nominal or real, you would then to get a percentage just multiply it by 100. Okay. Any questions on that idea before we keep moving? So real could still decrease if price changes. So the only way real GDP could decrease, because we're adjusting for prices. So real GDP only tells us about changes in output. So it wouldn't be that I have larger output. If real GDP went down, that actually means that I've already adjusted for prices so that I don't have changes in prices with my real GDP. Nominal GDP is the only thing that captures change adjusted for that with my real GDP. So real GDP only reflects changes in output. So the only way real GDP goes down is if my economy is producing less than before. Okay. So the next kind of problem we'll think about is, oh, which one did I want to do? I told you I was going to do a growth rate one later. Oh, I want to do this all in one question. So we've got several concepts. I could kind of combine these all into one, right? So let's say I gave you nominal GDP, right? I told you, what do I want here? So we'll start out with my nominal GDP of 600. I could then tell you that consumption goes up by 100. So it's increasing. So if that's the case, right, ultimately I might want to know what is my real GDP per capita, right? That's my question. From this consumption change, what's real GDP per capita? Well, I would need a few other pieces of information. So what if I also told you that my GDP deflator is 130? I also told you that the population is 40. Okay. So if that's the case, right, what would my kind of new nominal GDP be? Well, if consumption went up by 100, remember, how are we calculating GDP? When I go back to that income and expenditure approach, well, that's always nominal, right? Because I'm not adjusting for any prices there. So my new nominal GDP would be the old plus whatever that change in consumption was, right? So if I then want to think about, well, I'm looking for real GDP per capita, what would my real GDP be? Well, we said in the kind of prior one, right? My real GDP is equal to my nominal GDP divided by that price deflator. So I would take what? 700 over 130. This gives me approximately 5.38. Okay. Now, if I'm looking at this value, to go from a nominal GDP to a real GDP of 5.3, that would be dramatic inflation, right? So we need to remember that when I'm making that calculation for real GDP, we take that fraction and we always multiply it by 100. Okay. So in that kind of real GDP calculation, we always multiply this fraction by 100. So if I did that, right, I should get something that makes a little bit more sense, which is like 538. And I think if I keep the decimals here, it's just like 46, so 0.46. Okay. So I could stop there, like in a problem on the exam. I could just have asked you for real GDP, but we add one more thing, which is what's my real GDP per capita, which is really just my real GDP divided by population. So here I would have approximately 538 divided by that given population of 40. I would have a real GDP per capita of approximately 13.46. So this is like several concepts. This might be one of the harder questions on the exam because I'm taking multiple things here. Changes in consumption. How does that change my nominal GDP? Converting nominal GDP to real GDP, and then converting real GDP to GDP per capita. Okay. Any questions on this one? I'm going to add in one more thing that could be like a separate question. All right, so let's say, oh, just to make another point, if my GDP deflator was greater than 100, right? So how did we calculate that GDP deflator? Um, I could think about that GDP deflator as nominal over real. So the only way that's greater than 100 is if my nominal was greater than my real, which kind of keeping output the same, that would imply that if this denominator is lower, and then I also multiply this by 100. So if I'm adjusting for prices, the fact that my real is less than my nominal, going back to the other question, we said we must have had inflation, right? So if we have kind of constant output, but I see this GDP deflator, excuse me, is greater than 100, right? That would mean I must have had inflation. Okay. If it's less than 100, that would mean I have deflation. Okay. And hopefully, I think my camera's cutting in and out, so hopefully it doesn't cause any issues with anyone. Um, the other thing I wanted to kind of add in here, if we're thinking about something like real GDP per capita, so let's say I've got my real GDP in 2025, and I know my real GDP in 2024. Okay. If we had the same real GDP in both years, but the population grows, what must happen to my, or what would the relationship between real GDP per capita in 2025 be relative to that real GDP per capita in the older time period? Right? Well, how did I find GDP per capita? It was my real GDP divided by the population, right, in those two time periods. So if populations increase, right, I've got a larger population this newer time period, what's that going to do? Well, if I've got the same real GDP in both years, but the denominator is larger, that would drive this fraction down, which means that real GDP per capita must be lower in that year where I had a population increase. So that could be like a separate question, but kind of using these same concepts. Okay. Any other questions on that one before I keep moving here? Okay. I'll do a little bit of module 4. If we have some time, I'll still kind of return to some module 3 questions. But let's say I had, oh, I missed a thing in the chat. Does that assume? Yes, I'm assuming that I was just trying to kind of make the point about just the impact of population. So if we assume real GDP doesn't change, then the higher population would drive that real GDP per capita down. If you wanted to complicate, just to kind of get at these concepts, if you want to complicate this a little bit, let's say I told you that from 2025, or sorry, 2024 to 2025, that the output of the economy increased. Well, real GDP tells me about output. So if it's higher in 2025 or it increased, what would happen? Well, increases in that real GDP causes that fraction to go up. Here would be an answer where if I know that output went up at the same time, so did population, my real GDP per capita, I don't know what's going to happen. The change would be indeterminate. Okay. Any questions on that before we keep moving? Okay. So the other one that I want to work through here is let's assume I've got a production function. And here in the slides and stuff, I was usually using this as Y on the exam because this is really trying to measure output. What do we know measures output? Real GDP. So if I'm looking at real GDP, we said it was going to be my total factor productivity times my physical capital to a certain power, and then multiplied by labor and human capital to the 0.8. Okay. So let's assume I have a change in my physical capital. And here, just to make this a little bit easier, we're going to normalize human capital to one. So in certain equations, I'll tell you this. If we normalize it to one, I won't even include this in the equation that's displayed to you. Okay. So I'm going to exit out of this chat so it gives me notifications if somebody does enter something in. So let's say I've got a total factor productivity, or A, that's 14. Right? I've got my initial kind of physical capital, or K, is 200. And I've got that my initial starting labor is 200 as well. I'm going to start out here. Okay. If I then said, okay, what happens if physical capital increases to 300, right? And I asked you for what is the growth rate of this economy from that change. Well, what we would do, just kind of writing this out, and then I'll kind of make the calculation in Excel for us. But I would calculate my initial real GDP. So this would be 14 times 200 to the 0.2 times 200 to the 0.8, right? I would figure out what that value is. So I'm going to do this in Excel and we'll kind of switch over. Well, I can do the calculations. You don't necessarily need to see these. So 14 times 200 to the 0.2 times 200 to the 0.8 should give us a value of 3,000. I've entered this in hopefully correctly. Let me make sure. 200, 200. Yeah. Oh, nope. I put 15 in here. We had 14. So this is 2,800. After that change in physical capital, right, my kind of new real GDP, I would change that to whatever the new capital kind of value is. So I'm going to change physical capital to 300. If I make that calculation, it looks like I get 3,036.52 approximately. Okay. So if these were my two growth rates, so this is like my new and my old real GDP, how do we calculate growth rates? So growth rates, right? This is very similar to inflation, right? So I'm going to write these out just to kind of make the point of how these are similar. So when we were looking at inflation, we wanted to know something about changes in prices. So how were we doing that? We were taking whatever our new CPI was minus the old CPI, and then dividing that by whatever the old CPI was. Okay. Now, my growth rate is just going to be measuring output, right? So if I'm kind of looking at that, I'm looking at my real GDP in the new time period minus my real, I'm going to just shorthand this here so I don't have as much to write. Minus my real GDP in the old time period, minus where real GDP started out, which was the older time period. So I've got my growth rate formula. This is kind of combining two steps into one. You need to be able to use your production function and then think about what was my change here in my real GDP. So we've got the values. It's just a matter of plugging these in. So I've got 3,036.52 minus 2,800 divided by 2,800. So if I do this calculation in Excel here real quick. Oh. I get what, 0.084 approximately. Now, on the exam, I said most things I would ask you, I'm asking you for the percentage form. Okay. So what would I do? I would simply then just multiply that by 100. So I get what, about 8.4 would be my growth rate as a percent. Okay. Any questions there before we keep moving? So that's where I could give you a production function and then ask you to calculate a growth rate, depending on kind of what that change in either I could do changes in capital, changes in labor, or if we did have human capital, I could also do changes in human capital, but they would all really follow kind of the same same line of logic or the same procedure here. Okay. All right. So another thing that I kind of wanted to point out here, and I think we worked through one yesterday, um, but I think it's valuable to work through one more because this could show up on the exam. So if I had, we could even do that growth rate instead of doing inflation. I think I used inflation yesterday. So if I've got my growth rate as a percentage, we said that was going to be equal to the change in my growth rate. So I could think about this as, I'll just use time periods here. My new growth rate minus my old growth rate divided by the old initial starting growth rate times 100. Okay. So anytime sorry, I said the growth rate. Sorry, I'm talking, this is not growth rate. We're calculating growth rates. We do that with real GDP. Okay. Sorry, I'm talking and thinking ahead here. So how would I figure out, right? Let's say I told you the growth rate was 8%. So instead of doing this all kind of in just general form without values, I'm going to be giving you these values. I would just plug them in right away to kind of do the math, right? So I would kind of have this growth rate in percentage form. So this would be 8%, right? I'm then going to think about what if I told you the initial, here I'm going to give you what the real GDP was in the newer time period, and I'm trying to find that real GDP of the older time period, right? So once again, we did an inflation example yesterday. Here we're doing a growth rate example. So all I'm going to do is start to rearrange this equation. So first thing I have to do, if I give you that growth rate as a percent, I need to start doing kind of rearranging this equation. So I first divide by 100. That cancels. So if I divide this by 100, what am I really doing? Well, I'm converting that percentage into decimal form. So in the final equation we have, the growth rate that we're actually thinking about is going to be in decimal form. So I've got what? 0.08 here. And this is still equal to 500 minus the old GDP, old real GDP, divided by old real GDP. So I'm then going to multiply both sides by that real GDP in 2024. This would cancel. I've got my real GDP in 2024 times 0.08. I'm then going to add in that real GDP from 2024. This cancels. And I've got this. And now the only thing I have left on this side is that value of 500. So when we get to this step, and you don't have to go through the math if you can memorize this equation or you kind of have it written down in your notes in front of you. Well, if I have both of these here, I have real GDP in 2024, I could pull that out to the front and rewrite this as 1 plus 0.8. Okay. And then that's still going to be equal to 500. So how do I find this real GDP? 1 plus 0.08. I would divide both of these by 1.08. And that would be kind of what my real GDP is. Okay. Any questions on any step there that I used? So a general form of this equation, if I didn't have values, how do I find the real GDP of the old time period? Well, the real GDP of my old time period is equal to the real GDP of my new time period. And then what am I dividing it by? I'm dividing it by 1 plus that growth rate, but in decimal form. Remember, we kind of divided it by 100 up here. Okay. Any questions on that idea before we keep moving? Okay. Make sure I'm working through things. I've got some other things written down, so let me see what we haven't done yet. Um, so we've got inflation. Um, so I'll do one more thing for module 3, and I think then I've got one other thing. It's not focused on 1 and 2 a lot. Rest today. So let's do an example where I'm calculating GDP. So if I did this, I likely would use the expenditure approach. So if I'm thinking about how do I calculate GDP, it's consumption plus investment into capital plus government spending plus my exports minus my imports. Okay. So let's say that exports or X, let's say they decrease by 100. Okay. So what is that going to do? It's going to lower my GDP by 100. Right? So if I want that new GDP relative to my old GDP to still be larger, right? So I still want to see that my new GDP has went up even after this decrease in exports. What's the only way that that's possible? Well, it would have to be that this decrease in exports is overcome by any other change in one of the 4 components. So if that was the case, any increase in consumption, investment, or government spending, any increase that would be greater than 100, right, would still increase my new GDP because that loss of exports is overcompensated for by the increase in one of these 3 categories. So if I gave you like values, for example, if consumption went up by 300, then my new GDP is still increasing. If instead I said investment goes up by 50, well, the loss of exports is larger than the increase in investments into capital, so that one would actually cause my real GDP to be lower. So that one's not gonna work. Now, a trickier one to think about is let's instead think about if I had a change in imports. So what would the change in imports have to be in order for me to still see a higher new real GDP? Well, if I'm subtracting imports, the only way that GDP goes up is if my imports actually go down, because then I'm subtracting a smaller value. So how much would they have to go down by? Something that would be, once again, greater than 100. So if I had imports decrease by a value of 50, well, that actually wouldn't, right, overcompensate for the decrease in exports. Remember, a decrease in imports, right? All of these I was causing kind of increases in GDP. This would still, we would see a real GDP be lower. But if that change in imports was instead that it decreased by, I don't know, 200, well, now that decrease in imports adds more to GDP than we were losing from exports. So that one would also help kind of increase my new GDP. Yeah. So you might see a very similar question like this, where I tell you there's this initial change, which of the following would cause kind of increases in my GDP or cause my new GDP to be higher? Any questions on that before we keep moving? All right, where are we at in time? We got 20 minutes left. So I have got 2 that I really want to make sure we go through. Um, and they both kind of have a similar end result that I want to make sure we focus on. So let's say I've got my real GDP in 2025 Okay. I know that's going to be equal to whatever my nominal GDP was in 2025, but then multiplied by the CPI of an older time period divided by my CPI of the newer time period. So I've gotten a lot of questions on this. If you go to the slides, there's a COLA adjustment slide, which was adjusting for changes in the CPI or changes in inflation. We're not going to have any questions related to that. It gets a little bit trickier, and so I'm not going to kind of go over that. You didn't see any questions like that on the quiz. I also had a minimum wage example where instead of looking kind of forward in time, we were looking backwards. So these get flipped. Anything I give you would be similar to the question that we're just about to work through. Okay. So let's say I told you that we see the nominal wage in 2025, or sorry, nominal wage, nominal GDP in 2025 increase. Okay. And this could be nominal and real minimum wages. Everything would just be different notation. So if we see kind of this nominal wage increase, and actually let me color code this. So let's say the nominal GDP in 2025 is instead higher. Well, that would cause my real GDP to go up. Okay. What would have to be true if I saw at the same time something that caused a decrease in my real GDP? So the only way that there's a decrease in this real GDP is if this fraction, right, is less than 1. Okay. So if this fraction is less than 1, then the resulting change in real GDP, if I multiply the same value by something less than 1, it has to be lower. How would that be true? So if I'm kind of, instead of telling you that this is less than 1, let's say I just tell you that there is inflation. Inflation by definition is an increase in prices. So what do I know is going to be true? I know that if I have an increase in prices, my price index is capturing that. My old time period CPI would be less than my new time periods, which would make this fraction less than 1. So if instead I just gave you this information and told you, let's assume the nominal GDP in 2025 is higher. At the same time, we have, higher inflation, or there was inflation between these two time periods. What would the resulting change in real GDP be? And the answer would be, it depends. All right, we can't determine unless we know the relative size of these changes. Okay. Now, if I instead, I could do another example where let's say I did deflation, right? Well, that's reflecting that prices go down, in which case my CPI of 2024, right? Prices are going to be higher than my new price index, which would make this fraction greater than 1, which should actually also cause my real GDP to go up. So in that scenario, if instead I had deflation, I know real GDP would be higher from these simultaneous changes. Okay. I missed something in the chat here. So going back a ways, I think that you were talking about this example. If this is the one you're referring to, yeah, everything would be the same. It's just instead of writing kind of new and real GDP, it would be new and real prices, right? If we're looking at inflation. And there it's not a growth rate. Like that's what we're thinking about inflation here. Okay. So yeah, 15 minutes left. I want to think about instead a problem where I've got simultaneous changes here, and we're thinking about module 4 material, so changes in output. So, or changes in our factors of production that change output. So let's say, and this will be kind of an all-in-one question, so we'll hit a bunch of different concepts. So we said that our output of function, or y, which represented real GDP, let's assume it was a times k to the 0.5 times L to the 0.3. Okay. If this is the scenario, and let's say I don't give you values here. Um, so the first thing we'll kind of start out with is what happens if simultaneously depreciation is greater than the investments made into capital. And I should have started off, sorry. I just want to color code this to make it easier as you're watching the video or taking notes. And then simultaneously, I have that my labor outflows are less than my labor inflows. Okay. Well, if that's the case, right, we said that what is my current level of capital? It's my old level of capital plus the investments I made minus depreciation. Well, if depreciation is larger than the investments, this value is going to be negative, right? So my amount of capital is actually decreasing. So if capital is going down, that's going to cause my real GDP to decrease. We said, how do I figure out what my new amount of labor is, or what was the directional change in labor? Well, we had there, I'm adding in any inflows, any new workers or employment, increases in employment, but I'm subtracting out my outflows, right? This would be more people unemployed, more people leaving to other countries. And so if that's the case, right, we had inflows being larger than outflows, this is going to be a positive value, increasing our labor, which now what's going to happen to real GDP? I don't know. Now, in any of these examples, I'm kind of pointing this out a lot of the times where the answer is indeterminate. If I had other examples, like sometimes it's I know that it decreases, or sometimes it's I know that it increases. If these both kind of push real GDP in the same direction. Okay. Any questions on that idea? Since K is greater than L, we're done out. So here I'm not thinking about, I didn't give you what the percentage change was in these factors of production. So I was gonna, you actually anticipated what I was gonna do next. So let's say I instead just simply tell you that there is a change in capital or there is a change in labor, and it's the same exact percentage change, right? So let's say there's a 10 percentage change in capital, right? And there's also a 10% change in labor here. Okay. So if it's the same percentage change, right, I could almost think about here, it's going to be my capital was 1.1, right? Essentially, whatever my old capital was times 1.1, whatever my old labor was times 1.1. And so there, which of those 10% increases is going to have a larger impact? Well, whichever one is being raised to a higher power. So if I would have to tell you, and I won't ever give you one where I give you different percentages and make you do the calculation of taking it to the power and see which one is larger, although that's something you could do, just outside the scope of this class. But if I told you that there's the same percentage change in both of these factors of production, because that exponent on capital is greater than the exponent on labor, right? If I had a 10% um, decrease in capital, a 10% increase in labor. So maybe I think about here, I've got negative. It's the same percentage change, but that change in capital, right, is going to be larger than the effects of that percentage change in capital are going to be larger than the effects of that percentage change in labor because its exponent is greater, right? In which case, this change in capital was decreasing my real GDP percentage change in labor's impact. So if I gave you the exact same percentage change, looking at those exponents, you actually could tell me here what's going to happen to real GDP. It's going to decrease. Okay. And then just to touch on another concept, as long as we have this written out here, if I had the same percentage change in total factor productivity, what will always be the case, right? So if I have the same percentage change in total factor productivity, it's always going to cause a larger change in my real GDP than the same percentage change in any of my factors of production. And the reason why is because the power of my total factor productivity is one, which is always going to be larger. You'll notice in every example I give you, the exponents are always going to be less than one for our factors of production, capital and labor. And I could even add in here human capital if I wanted to, but the same concepts would apply. Okay. Right. So I think if there's anything else I want to say here before we move on. So these are all the ones I wrote out. I think that should be most of them. Are there any other questions or concepts or topics that you were just having questions on? I can try to come up with a question off the top of my head. A lot of these I had some ideas written down um, kind of ahead of time, but oh, I know a good one. If you're paying attention still at this point in the video, this one will be very helpful. So one thing that we might have rushed through a little bit from module 4 is this idea of the Kunetz curve. I hope I'm saying that right. Where we had growth rates of GDP and we had economic inequality. So we said the relationship is going to look something like this. Okay. So at lower levels of GDP growth, okay, so we can kind of think about here, if I'm giving you the information that I'm looking at lower levels of GDP growth or GDP growth rates, what's going to be true? Well, if I increase my growth rate any more from what it currently is, so if we then see at low levels of growth rates, we increase the growth rate, what's happening? Well, we're actually seeing an increase in my economic inequality. However, at low levels of GDP growth, if I continue to see that growth rate increase, what's happening to the changes in my economic inequality? Well, it's still increasing my economic inequality, but by a lower amount or at a decreasing rate. So at low levels of growth rates, increases in the growth rate will cause my economic inequality to, yes, to increase, but at a decreasing rate or at a lower rate. Okay. Now, at every level here, so this is that the fact that it's increasing a decreasing rate, any increase in GDP growth is still going to cause economic inequality to some degree. I mean, this is zero, so any level of GDP growth still results in some level of economic inequality. Okay. And then on the flip side of things, if I'm looking at high levels of GDP growth, um, if I see a further increase in that growth or that growth rate, so now I'm thinking about I'm at higher levels of GDP growth and I continue to see increases, well, what's going to happen? Just because this is going, right? Because this is going down, I want to kind of make a point here. Yes, my economic inequality is decreasing, but notice even at high growth rates, economic inequality is still above zero. So it doesn't matter what my growth rate is, if it's relatively high or relatively low. I'm always going to have some positive amount of economic inequality. Okay. It's just that the relationship kind of changes in terms of which direction is it pushing economic inequality, but it's always positive. Okay. Um, and then here, as I increase my growth rate, what's happening to the change in economic inequality? Well, it's decreasing, but at a higher rate, right? That slope is getting steeper and steeper. Okay. So here I could say at a higher rate, or it's decreasing at an increasing rate. And here we said it was increasing, but at a lower rate or at a decreasing rate. Okay. Now, something I could also do, wink, wink, is let's say I had high levels of GDP growth. So I'm thinking about kind of over here. If I saw growth rates go down, what's happening to my economic inequality? Well, if I start out at relatively high growth rates and then I go to a lower growth rate, my economic inequality, there it's actually increasing. So I'm just kind of changing the direction that I would be giving you in that problem. Okay. Any other questions? We got a little bit of time. Let me think about something I could just mention that might be helpful. So just a reminder, because I would likely kind of reference this when we're talking about growth rates or using this equation. So remember we said if I wanted to calculate real GDP in a new time period, it was my real GDP in the old time period. And if it's more than 1 year, that was times one plus my growth rate raised to whatever many years I'm trying to make this projection out for. So what are some things that would cause my real GDP to go up by a larger amount? Well, if my initial starting real, sorry, not my growth rate, what would cause my new real GDP to be even higher than kind of a starting scenario? Well, if my old real GDP is higher, right, then my new real GDP is going to be higher. As long as we have, and we never looked at examples where we didn't, as long as that growth rate is above zero. What would also cause my real GDP to go, or my predicted GDP to be even higher, increases in the number of years I'm trying to make the projection out for. And then what would also cause my real G anytime we had increases in that growth rate. Now, if I gave you values and asked you to make the calculation, for example, say real GDP started at 100, I've got a constant growth rate of 10%, and I want to make a projection out for 5 years. All you're doing is plugging in your values there. However, when I'm plugging in this growth rate, if I told you that the growth rate was 5.4%, when I'm using this equation, we said that growth rate always needs to be in decimal form, right? And I would just a good way just to remind, like, make sure you're not forgetting that is if I plug in the percentage form and like my old real GDP was 100, when I use if I plugged in 5.4 here, I'm going to see a real GDP that's like way higher, right? If I plug it in decimal form, it should be higher, but like something that's a little bit closer to that old real GDP or that makes a little bit more sense. Okay. In fact, it won't be like even 1,000. Like this could be like a huge value. Okay. So make sure when you're using this equation, you're using that decimal form of your growth rate, even if you're given it in percentage form. Okay. Um, so I think if you go through the old quiz questions and the practice problems, I would just think about like if I understand this concept, I think combining the concepts is the main thing that adds to the difficulty of the exam. If I'm studying those, I would also like you can kind of tell there's some softball questions in there. Maybe not spend as much time on those. Um, but really reviewing those practice problems. Reviewing, I think what's really important is the questions that I tried to work through yesterday that I gave you and the ones that we worked through today. I mean, I literally wrote these down to go through by looking at the questions on the exam. So and I tried to kind of, tell you different versions I could ask. And so really kind of going through the videos from yesterday today or your notes that you took on both of them, that would be a good way for those kind of harder questions to really prepare for those. Okay. So I can hit the time limit here. I'm going to end the recording, but if you have any additional questions in the chat or you want to ask, I'll kind of leave this open here.